Você me dá um ok quando você estiver pronta para transmitir. Muito bom dia, sejam todos bem-vindos ao seminário aqui do nosso laboratório. Nós vamos hoje ter a Clara Lingat, que passou conosco aqui quase 4 meses. Ela chegou em maio de Toulouse, na França, dentro de um convênio Bravitec, que é os que tem com a França. E nesse período ela trabalhou junto com a Marília, e ela vai hoje apresentar esses resultados sobre o soiling de um projeto que nós temos na Bahia. E a Clara, então, está fazendo essa apresentação de despedida. Nós gostamos muito de ter você aqui conosco, Clara. Espero que você tenha aproveitado muito, né? E agora a gente quer ouvir o que você fez.
Obrigada. Bom dia a todos. Eu sou Clara e estou fazendo um estágio aqui por 4 meses. Então eu vou falar sobre meu trabalho aqui, que é Soiling Analysis for Brotas de Macaúbas. Então. Okay. A início, esse é um resumo de meu trabalho aqui e de minha apresentação. Então, eu vou falar de presentation of the methodology and the presentation of the results, and so I will say a little conclusion. Mas, a início, eu vou falar um pouquinho sobre mim. Eu sou da França e minha família mora em Estrasburgo, que é norte. Aproximo de alemão e estudo em Toulouse. Tem 1000 quilômetros entre Estrasburgo e Toulouse. Em França, para estar engenheiro, você precisa de fazer 2 anos de aula preparatória e depois 3 anos de escola de engenharia. Eu fiz meus 2 anos de aula preparatória em Estrasburgo, European School of Chemistry and Polymer Materials. E depois, agora, estou fazendo a minha escola de engenharia em Toulouse, que é National Superior School of Chemistry and Technology Art. Okay. Então, agora eu, em fim do meu segundo ano, em área de engenharia de materiais. Então, tem bastante palavras por minha formação. E por passar em 3 anos, eu preciso de fazer um estágio em outro país. Então, é porque isso estou aqui. Desculpa. A início, que eu vou dizer sobre o Brasil, claro, é brigadeiro, porque eu prefiro brigadeiro. É minha preferida comida aqui. Mas, em sério, aqui eu moro com minha melhor amiga e nós viajamos em bastante lugar. Eu fui capaz de descobrir bastante diferentes culturas, bastante pessoas, bastante paisagens. Foi muito legal e eu sou muito feliz de conhecer todos. Mas Eu tenho bastante aulas de dança também. É uma grande parte de minha experiência aqui. E eu aprendo uma nova língua. Obrigada por sua ajuda e seu tempo por ajudar-me com português. Mas minha primeira coisa porque eu estou aqui é por trabalhar em fotovoltaica e UFSC laboratório. Então, eu não trabalho com fotovoltaica. É minha primeira experiência e eu nunca trabalhei com solar energia e agora eu descubro outra área que eu muito gosto. Então, por razões técnicas, eu vou falar em inglês. E eu acho que é melhor por todos. Okay, desculpa. So, first of all, I will presenting the methodology. So, the main goal of this project was study the effects of soiling on the performance of PV system, precisely on crystalline silicon and cadmium telluride. So we had 2 modules of each technology, one which was clean and the other one which was dirty. And the goal was compare the 2 modules to know the impact of soiling. So before a previous analysis was done, it was done 1 time per year and was only done on 1 module for each technology. For example, the data was collected when the module was dirty, and then it was clean, and the measure was down too. So the very good advantage of this previous analysis was they had not problem with correction with differences on the 2 modules, and yeah. So, but another way, this permits to have a global vision of the soiling impact of on PV system. So, the soiling station was in Brotas de Macaúbas in the northeast of Brazil. This area is a semi-arid area, and the location is indicated here. So this is a picture of the power plant, and the soiling station is now here. You can observe a picture of it. So at the left you have the system with the crystalline silicon, and at the right the cadmium telluride. The clean module, which is PV1, is here, and on the top it's the dirty module, which called PV2. It's the same principle for the cadmium telluride. Here is the PV1, the clean module, and on the top the dirty module, PV2. Here you can find the reference of the module that were used. So for this analysis we use different parameters. So the short circuit current, the power at the maximum power point, the irradiance, the temperature, and the rainfall were the principal parameters that we used to analyze. So the first idea was to do a soiling ratio, which is the measured output and the expected output. And the goal was to compare the two modules, the one that is clean and the one that is dirty. But we had few problems. So first of all, for the crystalline silicon, the reference cell is very different to the module. So the comparison was not very representative. And for the cadmium telluride, the two modules were not, one of the two modules were not clear. So the two modules were dirty, and it was not representative to compare it. So finally, we decided to use the soiling ratio of the short circuit current and the soiling ratio for the maximum power point. This equation is from Atonometrics. So this equation permits to compare the data of the module that we measure to the data of the data sheet of the manufacturers. For the cadmium telluride, as the two modules were dirty, we just compare one module dirty to the data sheet of the manufacturers. So, to do it, we needed to use the irradiance of the modules. So for cadmium telluride, we took the irradiance of the reference cell PV1. And for the cadmium telluride, at the beginning we used the irradiance of the clean module PV1 of cadmium telluride. And as I said before, the PV1 of cadmium telluride was not clean, so we cannot use it. And we decided to use the irradiance of the reference cell of crystalline silicon. But as we can see here, the soiling ratio is above 1. We can explain that because of the mismatch of cadmium telluride and crystalline silicon. The cadmium telluride has a blue shift, so it measures the reference cell of crystalline silicon measures less than the module of cadmium telluride. That's why we obtain a soiling ratio about 1. So finally, we decided to conserve the irradiance of the clean module, which actually were dirty, of the cadmium telluride. So now I will speak a little bit about the presentation of the results. So the first thing that we can see is that there is a difference between the soiling ratio of the short circuit current and the soiling ratio of the power at the maximum power point. For the cadmium telluride, as I said before, the two modules were dirty, so this is just a difference between the cadmium telluride which is dirty and the data sheets which given by the manufacturers. But for the the crystalline silicon, this difference is due to the IV curve and the non-uniform soiling. So we can see here that the difference between the value of short circuit current is not very huge comparing to the difference between the values of maximum power point. So that's why the short circuit current is closer to the value that announced by the manufacturer than for the power maximum, which is a little bit more far. So if we just speak about the crystalline silicon, the values were recalled from February to June. We can see here that when it's raining, the soiling ratio is closer than 1. So the performance of the PV crystalline silicon is better than when it's soiled, like for example here. So we can directly say that if the module is clear, the power of the module will be better. For the cadmium telluride, we cannot conclude because the two modules were dirty. But so we can see, for example, here the same day that even if it's raining, the shape and the distance between the 2 points doesn't change so much. So we cannot conclude about it. We need to have one module that is clean and the other one that is dirty to have a good conclusion. So to conclude in global, for the crystalline silicon, we can say that the rain permits to clean the modules and increase the power, which is good for us and that we searched for. The close value between the soiling ratio of short circuit current and the soiling ratio of maximum power points say that we have a slightly uniform soiling. At the inverse, for cadmium telluride, we cannot conclude anything with the soiling since the two modules were dirty. And maybe the difference between the soiling ratio of short circuit current and the soiling ratio of the the maximum power point are different because of the soiling and the non-uniform, but it's maybe also because of other reasons, so we cannot conclude about it. Finally, I want to thank you for your attention. Obrigada por sua atenção e merci de votre attention.
Muito obrigado, Clara. Alguém quer fazer alguma pergunta para Clara? Última chance, ela está indo embora amanhã. Eu tenho uma pergunta. I have a question. So you identified what the difficulties are to perform this kind of soiling studies. Regarding the thin film cadmium telluride, there's two main points here. One is that the cells are very narrow stripes, fine stripes, which run all along the module, and then we didn't have a proper reference cell. Okay, how do you think we could improve those measurements comparing with the crystalline silicon cell, in which you have another difficulty, which is the cells are square and large area cells, and then when you have inhomogeneities in the soiling, you see that effect reflecting much more than in the thin film.
So for to solve this problem, we can use the measure of the spectrum, and also we can use the, for example, a reference, which is crystalline silicon 2, but with a filter, and can represent the cadmium telluride. So I think it can be helpful.
Thank you. Mais alguém? Mais alguma pergunta? A orientadora dela não quer fazer nenhum comentário, algum... Não? Então tá, pessoal, muito obrigado pela atenção e participação aí. Mais umas palmas para a Clara. A gente gostou muito de ter você aqui.